Okay. We have these two equations with x double primes and y double primes, and whatever non-homogeneous part you have over here. It should be immediately obvious that if we add these equations, we eliminate y from the whole thing. So normally we're not going to add the equations, although we could, because normally we're going to have kind of mixed, we'll have second derivatives and first derivatives and stuff, and they won't match up in any way that allows us to easily eliminate one of our functions. But since we can do it now, we might as well. So kind of an unusual case, one that you don't expect, but you get 2x double prime equals t squared plus 4t. So we can immediately solve for x. Okay, so, immediately. Of course, this becomes just a second order linear equation with a non-homogeneous part over here. And we can actually solve this by two integrations, since the thing is, that we don't have any x primes or x's in here. We just have an x double prime. Integrate this twice. We're going to get t to the fourth over 8, not t to the fourth over 6, and t cubed over 3, 2/3 t cubed. Yeah, but of course we got the 2 there and stuff. Okay, so anyhow, we can integrate that pretty easily. We're not going to do that. We're going to follow our procedure. We're going to get two times the Laplace transform of x. Oh boy. I have a way of doing that. We're going to get 2 times s squared, Laplace transform of x, and then it's minus x prime of 0 minus s x of 0, and that's the Laplace transform of the right hand side. That's the Laplace transform of t squared plus the Laplace transform of 4t. And those are easy Laplace transforms. I can do this all in one fell swoop. I think I can do that. I thought, I'm writing 2. It's what I wrote in my head without looking, and it came out on S. It's easier and easier to make mistakes. Okay. So we're going to get that just by dividing both sides by 2. And then we've got to also divide by s squared, so 2s squared. And then we're going to have x prime of 0 over s plus x of 0. That's going to give us our Laplace transform of x. Okay, now we take this expression and we plug it back into the Laplace transform of the first equation. I don't know if I want to do that. No, just, okay, I'm looking at the x double prime. Yeah, if I do the Laplace transform of the first equation, and you get s squared L of x okay, so yeah, plus transform, not plus y double prime, so Laplace transform y double prime. That's going to be s squared L of y minus y prime of 0 minus s y of 0 equals t squared. Again, let's hope I'm doing this correctly. And now we've got L of x that we can plug in from here. So we have s squared times the Laplace transform of t squared over s squared and so forth. And there's our s squared times the Laplace transform of x. And notice that all these are just Laplace transforms that we can easily write out. Now the only L of y we've got is this. All the other Laplace transforms, again, are just expressed in terms of x and numbers. So we get L of y equals, it's a big long mess, but it's just single terms that are easy to inverse transform. Now there might be something else. I haven't looked at what the book does with one of these things. Not sure that it was really an advantage to do this, because of course we get kind of a long term here. We could work it out the other way by writing out the Laplace transforms. But when you solve for either the Laplace transform of x or the Laplace transform of y, it's pretty much going to come out equivalent. So I think it's probably just well to do this from the beginning. Now, of course, I could have written out these Laplace transforms and the s's and done a little bit of algebra to simplify this mess. But I've kind of chosen to keep it this way to show you where everything comes from and how everything moves through the equations and so forth. Once more, I don't think there's anything that's going to give you any trouble, but I want to take a quick look at your actual homework. I've looked at it, but I need to take a quick look again. Let's see if this thing will keep me signed in. Very inconsistent about when it kicks you out. Some days it's in a good mood, some days it isn't. Today it wasn't too bad. Okay, actually I've still got the camera on, there's no need to have it on.